Let's write the electron configuration for the cadmium 2+ cation. When you're removing electrons to make cations, metals typically lose electrons. You're not going to go in the reverse of aufbau. So when you're filling electrons, you follow aufbau, follow the periodic table, in other words. But when you're removing electrons to make ions, cations, you want to remove from the highest principal quantum number, from the highest principal quantum number. In other words, you want to typically remove S before the D's. Because when we fill, the D's are the last ones we fill after the S's. But we don't remove in that reverse order. All right, so here's cadmium. We get a bit different color. So we know if we follow alpha when we fill, because this is the here's cadmium, because this is the D block. We know the normal cadmium electron configuration is going to end. There's the noble gas as krypton, and then we're going to go all the way through following aufbau. Right, so this is n equals 1. There's your 2s. There's your 3s. There's your 4s. There's your 5s orbital. So we're going to get through 5s1. 5s2, then we're going to go all the way to the end of this D. This is 4D, okay? Because this is 3D, the D's are first available in the third principal quantum number, and then this must be your 4D. All right, so we know we're going to go into the 4D, and it's the last spot there, so cadmium is going to represent the 10th electron in that sublevel. So this is the normal electron configuration for cadmium. So what I'm saying is you don't remove, let me pick one more color, because we need to remove 2 electrons to get that 2 positive cation charge. So we don't remove from there. All right, we remove from the highest N, and that's typically, like I said, is going to be your S's before your D's. So if we need to remove 2, we need to remove those 2 first. All right, so your final answer is going to be, let me zoom out here. The electron configuration for the cadmium 2+ cation in noble gas notation is krypton 4d10. One more side note here. Let's go this way. Because the d orbitals are full or empty, those cations typically produce a clear, colorless solution. So that's what this is. The D's, if D's full or empty, you can expect a colorless solution, and that's what you get. All right, and the reason for that is maybe another topic.